Welcome to This Explainer. Today, we're diving headfirst into a massive, and I mean absolutely massive paradigm shift in how software is built. Now, you know the old way, right? Traditionally, building a full-stack system meant wrestling with complex code, hunting down bugs for hours on end, and just staring at documentation until your eyes blurred. It was painful, and it meant it could take months just to get a basic prototype off the ground. But as we're going to see today, AI is completely blowing up those barriers. We're looking at a fundamentally new way to work, where you can build robust, full-stack systems without writing a single line of traditional code. It is endlessly fascinating, so let's get right into how this actually works. Just let that quote sink in for a quick second. We're talking about building highly valuable, fully functional $10,000 apps in a matter of minutes. And when I say $10,000 apps, I mean the real deal. Things like a custom CRM perfectly tailored to your sales process, or an automated lead generation tool that qualifies clients while you're fast asleep. Historically, you'd have to hire an expensive development agency for that. But now, we're moving entirely past the friction of traditional coding, and honestly, even past those tedious drag-and-drop workflow builders we've all struggled with. By leveraging plain English prompts and agentic AI models, the barrier to entry has officially been shattered. Okay, so here's our roadmap for today. We'll start with the vibe coding revolution, followed by the magic of MCPs. Then we'll cover blueprint and link connections, architecting and stylizing, triggering and deployment, and finally, we'll wrap it all up with the future of software. Let's kick things off with Section 1, the vibe coding revolution, a true paradigm shift. It's crazy to think about, but just half a year ago, if you wanted to build an automation without code, you were stuck using traditional workflow builders. You basically had to map out this node-by-node logic, staring at a giant spaghetti web of connections until your eyes crossed, just trying to glue a few simple steps together. It was slow, and you were always bottlenecked by a single agent. But today, we've entered the era of vibe coding with platforms like Google's anti-gravity. Instead of manually connecting nodes, you literally just use text prompts. You describe what you want in plain English, and the platform uses parallel agents, meaning you can have 5 or 6 agents all working on independent tasks for you at the exact same time. It's self-healing, it actively thinks, and it just builds exactly what you ask for.
Moving right along to Section 2, the magic of MCPs and how we connect AI securely.
So you might be wondering, how does this AI actually interact with your real-world business data? Well, that's where the MCP, or Model Context Protocol, comes in. Think of an MCP like a universal remote control for your AI. On its own, an AI is brilliant, but it's totally isolated in a box. It has no idea what's on your calendar today, but an MCP securely connects your AI directly to the external apps you use every single day. Notion, Fireflies, Google Calendar, you name it. Normally, you'd have to manually copy your meeting notes, switch tabs, and paste one into a database, which is super tedious. With an MCP, your AI can literally reach over, touch, and pull data from those services invisibly to get the work done for you. It's a real game changer.
And this effectively turns your system into a 500 IQ AI copilot that knows everything about your business. A great way to visualize this is to think of the AI environment, like anti-gravity, as a state-of-the-art fighter jet. The AI models themselves, whether it's Claude or Gemini, are your pilots. So you essentially have a super genius intern sitting at the controls, armed with universal remotes to all your databases, completely ready to execute your commands. But hey, even a genius pilot needs to stay sharp, right? When you're building these systems, you have to watch out for something called context rot. You see, every AI model has a specific context window, a strict limit on how much information it can hold in its active memory. If you throw too many prompts at it in a single session, the model gets fatigued. It loses track of its goal, and it starts to hallucinate. It's kind of like us after our third back-to-back Zoom meeting of the day. The fix is super simple but absolutely crucial. Just open a fresh chat window regularly to keep your AI pilot focused and on track.
All right, on to Section 3, blueprint and link connections, setting the foundation. Because, let's be real, having a 500 IQ intern is completely useless if you don't give them crystal clear instructions. That is exactly where the BLAST framework comes in. It's this definitive, repeatable 5-step playbook for building systems without traditional code. Blueprint, links, architect, stylize, and trigger. Whenever you're building an app, you follow these 5 steps. Why? Because while AI gives us unprecedented speed, frameworks like BLAST give us the reliability we desperately need. Step 1 is the blueprint. This is where you lay out the vision. First up, you establish the North Star. What is the actual tangible outcome we want here? Then, integrations. Which MCPs are we connecting to? Next is the source of truth, which is just a fancy way of saying where does the primary data live?
Then the delivery payload. You need to know exactly where the final result is going. Is it a daily email summary, a quick Slack ping, or a new row in a database? You have to know this before writing a single prompt. And finally, behavioral rules, the specific logical constraints the AI must follow. If you give it poor instructions, you're going to get poor outputs. The blueprint ensures your AI knows its exact job from minute one. Step 2 is links. Now that the AI knows the master plan, it needs the connectivity to pull it off. In this phase, we establish our MCP server access and securely test our API credentials. The AI performs what is essentially a virtual handshake between scripts. It reaches out to your Notion or your database to guarantee it can actually communicate before it tries to build anything. And here is a massive pro tip from the source material. Keep your active tool usage under 50. Why? Because anything over 50 starts eating into that active memory we talked about earlier, which leads you right back into context rot territory. So keep it lean to keep it focused.
Now for Section 4, Architect and Stylize Apps, Building and Designing.
The whole point of this section is making sure your app doesn't fall apart like a $2 suitcase the second a customer actually tries to use it. Large language models are inherently probabilistic. If you ask them the same question 100 times, you might actually get 100 slightly different answers because they're basically just next word prediction engines. But your business logic? That has to be absolutely deterministic. If a customer clicks submit 100 times, it needs to do the exact same reliable action 100 times without fail, no exceptions. To solve that, we use this brilliant 3-layer architecture. Layer 1 is the architecture. These are your technical SOPs that clearly define the goals, inputs, and edge cases. Layer 2 is navigation. This is the reasoning layer. It smartly routes data around, and this is key, it doesn't execute complex tasks itself. That is left to Layer 3, the tools. These are hard-coded, deterministic Python scripts that run exactly the same way, every single time. By separating the AI's fluid guessing game reasoning from the rigid, hard-coded execution tools, we can finally guarantee enterprise-level reliability. And to manage the back end of these apps, you need a robust database. The source material highlights Superbase, and they describe it perfectly as Microsoft Excel on steroids. It's basically this highly supercharged spreadsheet that acts as the back-end memory for your app. For non-developers out there, think of it this way. This back-end memory stops your app from having total amnesia every time a new user logs on. It stores all the user data, inputs, and logs securely, so the whole experience feels seamless. Once the architecture and database are locked in, we move to step 4, stylize. Obviously, functionality is crucial, but first impressions matter immensely. This phase is all about refining the payload, making sure your data outputs look fantastic, whether that's a beautifully structured Notion page or clean Slack blocks. But the real secret weapon here is something called UI sniping. This is a super clever trick where you go to component libraries like 21st or CodePen, find these gorgeous pre-built design components, and just instruct your AI to adapt that specific code into your app's front end. Literally eliminates hours of tweaking CSS, and it makes a complete novice look like a pro designer in minutes. Bringing us to Section 5, triggering and deployment running autonomously. Now we've got a beautiful, highly functional app, but we need it to work while we sleep. That's the 5th and final step of the BLAST framework, trigger. You deploy your fully built app to a cloud platform, like Modal or Rozelle, and set up scheduled internals. Let's walk through what this autonomous flow actually looks like. At minute 1, your AI pushes the code live. Let's say you set it on a 3-hour interval. Okay, hour 3 hits, the trigger activates. In the very first minute of that hour, your app spins up, runs all its scrapers or data updates, and then, this is the best part, at minute 2, the app immediately goes back to sleep. Going right back to sleep is huge because it saves you a ton of cash on server costs. Highly efficient and entirely hands-off. Let's zoom out of it for our final section, Section 6, the future of software beyond traditional code. With all this mind-blowing AI capability, it's easy to think older tools are completely dead. But hold on, we don't want to throw the baby out with the bathwater here. Traditional workflow builders like N8N or Make, they still absolutely rock when you need deep visual debugging or when you're building incredibly complex, strictly deterministic API connections where every single step has to be rigidly mapped out for compliance. However, for rapid development of full-stack systems where you want to leverage autonomous parallel agents, text-prompted vibe coding is the undisputed future. It simply moves faster than traditional nodes ever could. We have literally moved from untangling messy, node-by-node logic to just describing the apps of our dreams in plain English and watching them assemble themselves through the BLAST framework. The technical gatekeepers, they're gone. The tools are basically free. the barrier to entry for creating incredible software has officially dropped to zero. You've got the tools, you've got the framework, and you've got a 500 IQ pilot sitting right there ready to go. So, what $10,000 app are you going to build next?